Yep, today's the 26th. And where is oh, there we go.
26th. Happy birthday. And I enjoy it by going to parent-teacher conferences. Yeah.
Hold on, I gotta pause the recording because you guys are talking about resume. The next couple 3 weeks are going to be the art of solving quadratic equations. I'm not going to go nuts in this class. I don't think we're going to do like imaginary solutions, and we're not going to like graph quadratics and stuff like that. So I'm going to give you the non-algebra 2e version of this unit. It's kind of more in line with like an algebra 1e unit of this version of this. So you should recognize it. So I'm going to put a math problem up here, and I want to tell you that this is not what we're doing today. Okay, I just want to show you that this is what we're doing today backwards. So if I gave you that problem, and I can say that you should know how to do this because we've done a unit. You've actually already taken a test on this. You took a test on adding and subtracting polynomials, and then there was also multiplying polynomials. So you'll remember this as like 2 workers, 2 jobs, right? And so if we took the x and we multiplied him through, we would get x squared, right? And then if we multiplied him to the back end, we would get minus 6x. We agree? Okay, and then the next thing we're going to do is we're going to take the positive 4, and we're going to multiply him through, and we're going to get plus 4x, and then we're going to multiply the positive 4, and we're going to get negative 24. And you should not feel like you're seeing this for the first time. Again, we've literally already taken a test on this. So, and then you can take these two in the middle and you can add them together. And that leaves you with x squared minus 2x minus 24. Is that looking like something we're good at? Okay, so what we're going to practice today and Monday is the fine art of doing exactly that, only in reverse. Okay? So instead of me giving you the 2 red parentheses and you working your way up to this trinomial, I'm going to give you the trinomial and you're going to work your way backwards. That is called factoring, the fine art of taking something and breaking it into pieces that multiply to make it. It's no different than like in 4th grade, if your teacher said, hey, think of 2 numbers that make 12. And you're like, ooh. She goes, yeah, Marcus. And you say 3 times 4. You factored. That's literally called factoring. So we're going to do the high school version of factoring, and we're going to take the white problem and work it backwards to become the red thing. We clear? So that's the mission now for the next little while. And we'll do a bunch of examples today. They'll get harder, by the way. You'll feel like you could probably want to fall asleep after like the first 5 examples. Don't, because they get harder. And I'll tell you when that happens. I'll give you a warning because there is a clear moment at which you go, okay, this just got harder. So let's do this one. And I'll walk you right through the process, okay? I promise. So what we're trying to do is create a math problem. So at the bottom, the lower part of the screen, I'm writing a math problem that I could hand to someone and say, hey, Diedrich, multiply this out. And if he did the 2 workers, 2 jobs workout problem, he would get x squared minus 3x minus 18. That's the goal, right? So we talk now about, okay, what has to be true? Well, let's think about when you multiply the things in these red blanks, they have to make x squared, right? So what has to go in the 2 blanks? 2 x's, right? So the only way this is going to work is if I take x and put them there. Good. Now the other part of this is, and this is always 100% of the difficulty of teaching this is what we're about to talk about.
The whole way.
Yeah. I appreciate that. Thank you. I love them both.
I'll probably get caught for this one, but
that's okay. I'm sure she knows that you were doing it for all the right reasons. This is the hardest part of teaching factoring right now. Boom, here it comes. And if you're willing to hear me out on this, just like a critical minute and a half, then you'll be so much better off. The next thing you absolutely have to look at, and I mean have to, I mean have to, is the sign in the yellow box. I tried to teach this 1,000 times and I feel like I'm only successful about half the time. You have to look at that yellow box because that tells you that the numbers you're going to put in these two blanks eventually are going to multiply by each other. And when you do that, you're going to get a negative 18. So I ask you this, if you were to fill two numbers into my yellow blanks, and I don't even want to know what they are yet. I know that some of you might already be ahead and know. Just generally speaking, if I said to you, write me a multiplication problem, but the answer has to be negative, what would have to be true about your two numbers? One of them has to be negative and one of them has to be positive. And you might think that that's obvious. You would be amazed every year. This is where I spend the most time is talking about that. That one yellow boxed sign is the deal breaker for a lot of people. So if I multiply two numbers in the yellow blanks and they make negative 18, all I know right now, come hell or high water, is that one of these numbers is positive and one of them is negative. Now, what I'm not sure about is, do I have them in the right place? And that's why we always use pencils, is because they're easy to erase. When we realize that, um, oh gosh, I wish I could switch those signs. It's nice to be able to do that. So there are parts of it that's okay to do in pen. Like everything you see up here in red and white, I think would have been great to do in pen. But the moment we start putting signs down and like numbers, it's a good idea to switch to pencil because there's going to be a lot of oopsie, erase, try again, erase, try again. Does anyone have any questions so far? I mean, we agree that the two red numbers, x and x, have to make x squared, right? And we agree that if we have one positive number and one negative number, they will multiply to make a negative, right? Okay, so now let's get down to the nitty gritty. What we're going to do next is we're going to start thinking about, okay, not only do these two numbers in the yellow blanks have to multiply to make a negative, they quite specifically have to multiply to make negative 18. So this is where knowing your times tables is really a boost, right? And I have resources available. I've got, like, I gave you that piece of paper that has all the times table factors, I think, on it.
It's a picture of that.
Yeah, so that will come in handy for you if you don't know your times stuff really well. So what's one combination of numbers that makes 18? Yeah, so there's 3 times 6, there's 2 times 9, and there's one other one. What is it? You bet. Don't ever overlook the what seems to be like, well, why would I use that? It actually works sometimes. So here's the deal. If this problem, by the way, everything I give you for the next couple, 3 days is going to be factorable. I'm not going to throw any curveballs at you and like say, surprise, this problem wasn't doable. Everything is possible. So one of these pairs of numbers has to work. So I want to show you what it looks like when we fail. It's important to embrace that failing is going to be a normal thing for the next few days. So let's just say I go, I don't really care. I'm just going to pick a 2 and a 9. So far, here's what I can say. I can say that x times x makes x squared. I can check that off my list. And I can also say, because I'm a big kid, that 2 times 9 makes 18, or in this case, negative 18, right? What I'm trying to make is a negative 3x when I'm done adding a couple of things together. If you were to multiply these together, what would you get? You would get positive 2x. Good job. And if you were to multiply these together, what would you get? Negative 9x. And it's okay. It's okay. It's okay. But if you look at those two upside down purple rainbows, you ask yourself, I can multiply anything. You remember this? Have you seen this before?
Yes. This is one I struggle.
Not this time. Not this time. So if you add those two purple upside down rainbows together, what is 2x minus 9x? Add these. Right. And then you look at the middle of the problem and you realize that's a fail. Like we don't want them to add to make minus 7x. We want them to add to make minus 3x. So that's when we chalk it up like this. Watch what I'm going to do with my pen. Are you ready? Ready? That doesn't work. So what I do is I make a list of all the things that could work. And when I prove that they don't, I cross them off and I don't check them again. And now we're back to ground. Not, you know what? Never mind. We're not quite fully back to ground zero, but we are kind of resetting. So we can chalk 2 and 9 up as a fail. What else would you like to try? Let's try 3 and 6. And only because I just barely heard you say that before whatever else I heard. So I'm going to put in a 3 and I'm going to put in a 6. And again, I say this a lot, and I never know if anyone knows what I mean. You don't get any gold stars around here for accomplishing this. We all agree that the red x's make x squared. Whoop-de-doo. And we all agree that the 3 times -6 makes -18. Whoop-de-doo. I feel like a total failure when a kid thinks that like that's what factoring is. That's easy. Factoring is about what I can't control. And what I can't control is these upside down purple rainbows. And so what do the inside ones make? What do the outside ones make? Now add those together, what do you get? So we have a winner. So in this purple box lies the answer to this problem. That's how we factor, is we're basically doing the multiplication in reverse. Instead of me give you problem, you multiply it out. I give you answer, you unmultiply it back. Wow. Right?
This is the one that we had to color for.
Okay. I didn't tell you you had to.
I had to.
Let's do x squared plus 5x minus 24. So again, I'm using a pen right now. Okay. I mean, I'm always using a fake pen, but here, this is the part I'm going to say I can do this in pen. So here it goes. I can put my 2 sets of parentheses in pen. What do I know goes in these 2 red blanks? I know that I have an X and an X. It is exactly at this point in time that I would set my pen down and now switch to a pencil, because everything that I do from here on out is a guess. And with guesses come the possibility of wanting to erase them. Do you guys remember what I said is the next absolute mandatory must huge thing to do? Which sign? Yes. This one sign right here tells me that the numbers that I put in these 2 yellow blanks have got to eventually multiply to make -24. What does that mean about the numbers themselves? It has to. It's not even up for debate. One of them has to be negative, one of them has to be positive. And again, that has to be done in pencil because you later might want to switch them and put the plus before the minus. So don't lock yourself out. And now it's a good idea to go over here off to the side and make a list of all the possible numbers that make 24. So I got 4 times 6. What else? 1 times 24. I like it. 3 and 8. What else? There's one more. We already got 6 and 4 up here. So one of these possibilities, one of these pairs is going to work. And so we're going to try one. And if it doesn't work, we're going to cross it off and try another one. There's no trick. Sometimes kids go, I know you're holding out on me. Like, what's the trick? The only trick is you just have to practice a lot. And then eventually you just start to go, oh, I see it. Does anyone already see what combo we want? Take a shot. 3 and 8's fine. Like, that's great. So let's just try it. Let's put in a 3 and an 8. Let's put in 8 here and 3 here like this. The thing about being a good factor, you're a good factor if you just roll your sleeves up and dive in. A good factor doesn't sit and stare at it for 5 minutes. So let's try this. And again, I tell you, I implore you, you do not get any gold badges around this place for making x squared and -24. Like you're in high school. I assume you can do that. Where you earn your star is the upside down purple rainbows. What does the inside rainbow make? What does the outside rainbow make? Just add those together. What do you get? Perfect. The signs. Right. And so this is a point in time where I add them and I go, oh crap, I got -5x, but what I wanted was plus 5x. So this is when we realize, okay, don't move anybody. Don't move x's, don't move 8s, don't move 3s. I got the right number with the wrong sign, so I switch my minus plus to a plus minus. And then the balance comes out correctly because now what do the inside make? The inside rainbow? +8. There you go. And now the balance comes out to plus like we wanted. Okay. So far, so good. You okay?
Yeah.
Repeat after me. I love factoring.
I hate it.
This is all we're doing today, by the way. We're going to be interacting like this for the rest of the period, and then I'll have you working on Monday. I got to be gone again Monday. We moved, we bought a different house, and we're in the process of trying to get things out of old house into new house, and time's a ticking. So I got to be there Monday to help some guys move some stuff and tell them where to put stuff. So yeah, I don't like this, but I do have to be gone again, and I'm sorry. So yeah. So I start out with what I know for sure. I put my X's in here. And then I think about, okay, if this is a plus sign, that means that the two numbers that go in these yellow blanks have to multiply to make positive 12. Couldn't have said it better myself. So they could either be both negative or they could both be positives. We agree? Okay. So the question for me is now, like, I don't like a 50-50. I don't want to wonder, like, which one is it? And so how do we figure it out? Yes, the 13 only bails us out in a case like this. Normally, I don't give a hooty-doo about the middle term, but in this case, 13 says, like, yo, I got you. I'm going to tell you now, since you're sitting there kind of 50-50'd, I'm going to tell you that both of your signs are definitively pluses. You already knew they were both the same, but now you know what they both are. Okay, so only look at the sign in the middle if you have a reason to. If the sign on the back leaves you like a little bit wondering. So the factors of the number in back are 1, 12, right. And what do we want to try? If we try 1 and 12, we're going to have some immediate success with this because, and again, yes, yay, you made x squared. Yay, you made 12. I'm really trying to drive that point home. You don't turn in a test and say, look, I made x squared in 12. So could a sixth grader. Like, I'm not going for that. I'm going for the purples. What do these make? Plus 1x. And what do these make? And last I checked, plus 1x and plus 12x make exactly what we're looking for. The answer is in the purple box. Got it? So let's do a couple more, and then I'm going to up the difficulty level. Does anyone by chance remember, since you've all seen some version of this, what makes the difficulty level go significantly upward? There's a number someplace. I can put a number someplace in front of the first x squared, right? And so that's what's going to change here in about 7 or 8 minutes, okay? Just be advised. So let's do another kind of a warm-up guy. Let's do x squared minus 22x plus 40. Good. So I start with my shells. I like to call them shells. You don't have to. They're parentheses, but shells just sounds fun or cool. So I'm going to put my x's, and like Micah said it pretty quick, the order that you have to do this in is first you look at the plus. I suck at teaching this clearly because I just can't get kids to do this. They're like, just look at the plus. What does the plus on his own simply mean? That they're either both positives or they're either both negatives. That is not up for discussion, right? And then I say, well, I could use an assist. And that's when I go to this guy, my homie, negative 22 says, I got you. They're both minuses. They're both the same because of the plus. They're both minuses then because of the minus on the 22. Got it? And now we think about numbers that multiply to make 40. So there's 1 times 40. There's 2 times 20. There's 4 times 10. And 5 times 8. I think that's it, right? That's it. So at this point, what are my options? I guess. And I'm telling you, it's a guess for a while. And then once you get the vibe, like the flow, and you get to just groove in this stuff, it feels less guessy. But right now, I don't care if you just guess. Take a shot. What do you want to pick? 10-4, right? First one I heard, so I'm going to pick it. I'm going to put a 10 here, and I'm going to put a 4 here. All I'm interested in is what do these inside purples make and what do these outside purples make? That's what this is all about. What do inside purples make? What do outside purples make? And put those together, what do you get? Which is a fail, right? And that's okay. Failing to me is a success because it's one less thing I got to worry about later. Every time I miss one, I'm closer. So I can look at 4 and 10 and say, well, you're out. What else could we try? Let's try 2 and 20. What do the inside purples make? What do the outside purples make? Add those together. Jackpot. There's ways, if you were to look on YouTube, you could find other methods for factoring, like using grouping and little freaking box diagrams where you put this here and put this here. What I decided a long time ago is that the more of that you do, you lose the process of what you're actually trying to do. What we're trying to do is just build something that works, and we're doing it in a sensible way. We're not doing it in some weird abstract diagram way where we don't even know like what the hell we're doing. Like, why did we put that there and there? So if you go to YouTube, be careful, because some of the methods are a little bit more confusing than they're worth. Okay, let's go again.
Well, we have a test on this like probably next week.
I don't know if it'll be next week, but you will certainly at some point, yes, have a test on that.
Next week.
I don't really want to talk about it. Let's just pretend she didn't say next week. Let's go back in time. Shari, would you ask your question again, but say, well, we have a test on this someday. Would you do that again?
This Sunday?
Someday.
Someday.
Oh, is
Could
it?
you try it again?
We'll have a test on this Sunday.
Someday we will. Yeah. There we go. That was nice. So again, the key is how do I start? And how I start will determine whether or not I get through this. I place my X's because I know I have to. I look at the sign in the back, and because he's a negative, what do I know? So there has to be, you don't have to look at the other dude. And that's the beautiful thing, is when the one that I just put a gold box around is negative, I don't give a hoot about the one in the middle. If the one in the back is a negative, then I just know there's one of each, and I move on. If there's one of each, that's all I need to know. Now we go and we make a list of numbers that multiply to make 30. And they are 1 and 30, 2 and 15, 3 and 10. You got it. So you would look at this and say, how many pairs are there? And I'm not trying to insult your intelligence, but how many pairs of numbers are in my bracket over there? 4. And here in a couple of minutes, that's going to change to be 8. Do you guys know why?
8, because you can flip them around.
Because you can flip them around, and that matters. It doesn't matter right now, but it's going to matter here in a few minutes. So right now we look at that and say, well, there's only 4 things to try. Here in a bit, it's going to double because every pair can go forwards, backwards. So just be advised. What do you want to try first? Let's do 5 and 6. You care if I just do 6 and 5 like this, or yeah, whatever, right? So again, I already know, duh, that x and x make x squared. And I already know that 6 and -5, duh, make -30. No gold stars. I earn my success with the upside down purple rainbows. What does the first inside one make? Good. And the outside one is -5x. And if I add those together, what do I get? I get plus 1x, exactly. So here we go again, air quotes, I got the right number, but I had the wrong sign. Like I didn't want plus 1x, I up here obviously wanted minus 1x. So I have the right everything. I just need to take my plus minus and change it to minus plus. It would not work. If I put in plus 30 and -1, my inside rainbow connector now makes plus 30x. My outside rainbow connector makes -1x, and those give me plus 29x. As long as your plus goes with the 5 and your minus goes with the 6. That's what matters. So like on the board, I might have x minus 6, x plus 5. You might have x plus 5, x minus 6. We still both have x plus 5. We still both have x minus 6, so we're okay. Got it? It's who you're with, not where you are, basically. All right, you guys ready to jump it up?
You say 2.
The thing about those last 5 problems that we did are They do reach a point where it's almost gets easy to look at them and know the answer already. Like you know when to pick 5 and 6 and 3 and 8 and stuff like that, just because of the number in the middle. Now we lose that luxury. Like all bets are off. And at this point, it becomes a heavy duty guessing game. So let's begin with what we know. If I were to write part of this in pen, here's the part I could write in pen. I would build my shells. And what would have to go in these red blanks to make 2x squared? This will not work. We have to agree first off, right out of the gate, that if I put x's there and I multiply them, they would only make x squared. But if I do what Foxy said and I add a 2 onto the front of one of them like this, now when I multiply these, what do I get? Which is what I need. Nope, there's no numbers in front of our parentheses. That'll be when we have GCFs, and we're not going to do any of that. So I don't think ever in this. Right, we can do that if you want, but I'm gonna leave it out of the way. See, it's not hard. Really, it's not. Okay. Okay. Do we have any questions so far about the 2x and the 1x? And if you want to put 1 on your x, put 1 on your x. I'm not going to give you grief about it. I promise. Add the 1 if you like. But just know that we need this much. And now I switch from pen to pencil because, well, let me say one more thing. Because of just this, what do we know about our signs? Right. And again, there is not like a what about, what if, what about, there are no what ifs. If the number in back is negative, one of them has to be positive, one of them has to be negative. And now it becomes critical to use a pencil because I might have those in the wrong spot. Right? So the yellow now marks the beginning of pencil time. And so I head over here just like I always have, and I make a list of the factors of 20, and they are 1 and 20, 2 and 10, 4 and 5. However, what we need to say now is that 5 and 4 is another combination, as is 10 and 2, and as is 20 and 1. Now, I'm not saying you have to write it both ways, but what I'm telling you is this. If you test 4 and 5 and it doesn't work, don't cross out 4 and 5 because you have to try them backwards too. So if you don't want to write all of this down, I'm erasing it right now, that's fine. But like, let's try 2 and 10. I want to show you what I mean. So let's say that I just say, what do you want to try? And you just said 2 and 10. I don't care. So if you put 2 here and 10 here, what do the inside ones make? What do the outside ones make? Negative 20x. And if you add those together, the two purple numbers, you agree you get negative 18x, right? The worst thing you could do right now, watch my big fat purple pen, is go like this. 2 and 10 are not dead to me yet. They're dead to me in that order, but watch what happens when we move them around. This didn't happen before. But now if I change their relative positionings, the entire power dynamic in this problem changes. If I put the 10 here and the 2 here, what I've done now is I've effectively neutered the number 10. By putting the 10 here, he doesn't multiply by as much. What do we get for the inside? We get 10x. And what do we get for the outside? So you see, we kind of weakened the power of that 10 by putting him where we put him. And just because we're using 10 and 2 doesn't mean we've tried 2 and 10 or vice versa. But now I think we can agree when you add the purple numbers together, we failed. At this point, now that you've tried them in both orders, you can now show 2 and 10 the door. Got it? All right, then. What else would you like to try? In that order? Okay, so let's try 4 and 5 in that order. So we're going to put a 4 in the first one and a 5 in the second one. And let's just see what happens. So when we do our purple connectors in the middle, what do we get? What do we get on the outside? And when we add those together, what do we get? Negative 6, which is, it's a fine, but it's still a fail, right? But again, I don't cross out 4 and 5 because I could flip them. And again, the entire power, the whole thing changes. Listen, look it up here. If you'd be so gracious and kind, seriously, look up here. Whatever number goes there gets buffed, like in a video game, like a power up, like Mario eating a mushroom, how he gets bigger. Why is that such a special location to put a number? Because it's going to times by the 2. But when I put whoever I put there gets buffed, right? So that's like the buff spot. And so by putting the 5 there, I buffed him to make the 10, which is why we overshot the 3. So then we say, well, maybe we've got a shot the other way. Let's try switching these idiots. Let's put the 5 in the first spot and the 4. Let's just see what happens. It changes the entire dynamic. What do the inside purples make? Plus 5x, good. And what do the outside purples make? And add 5x and negative 8x, and what do you get? So we're on, yes, we got the right number with the wrong sign. And so everyone is where they need to be. If you switch the 2x and the x or the 5 and the 4, you're done. It's over. You're busted. Leave the 2x, leave the 5, leave the x, leave the 4, but change plus and minus to be minus plus. And now check it for yourself. The 2 in the middle now make minus 5x. The 2 on the outside make plus 8x. Add those together and you get plus 3x all day long. Got it? Okay, let's go again. You guys getting this? Okay. All right, next one. So when I build my shells, what can I take to the bank? What can I deposit and say, I'm sure? I do have a 3x and an x. That's not up for debate. Good job. Nope. The fact that the number, good job, Foxy. Yes, the fact that the number in the back, the one I'm pointing to, is a plus means they are, come hell or high water, either both pluses or they are definitively both minuses. That's when I default to my assistant in the middle, and the 11 tells me, oh, I got you. They're both minuses. They have to be. It's a team effort. The 6 tells us one side of it, and the 11 finishes the story. You're fine, buddy. Now, there's not a lot of ways to make 6. There's 1, 6, 6, 1, 2, 3, 3, 2. What do you guys want to try? Let's try 3 and 2. And again, this is what I like how quick you guys dive in. I like that you don't sit there and analyze it. This is, you will start to analyze it more when you're getting through the assignment. You'll start to think differently. I love the way right now you're just diving in. Cold swimming pool mentality. Just jump in. So this will not work. Let's verify that it does not work. We get minus 3x in the center, and then we get minus 6x on the outer edges. Add those together and you get minus 9x, and you're like, dang it. So why don't we, before we kick 3 and 2 to the curb, why don't we try them in a different position? Let's try switching the 2 to the front and the 3 to the back. They still make 6, but the power has changed. What do the 2 in the middle make now? Nice. So we get negative 2x in the middle. Yep. And then add those together, and what do you get? I'll be darned. So there's our answer. Where you put the numbers makes all. That's good. I'm going to give you one. I'd like you to try it all by yourself. Okay. Yeah.
Good. Why don't you see? Actually, I have the cool
I haven't minded the air. I mind the noise. The hum makes it so hard to hear people. I love this quiet. I don't have to raise my voice. You don't have to raise your voice. It's beautiful. So I'm going to assume that you guys have gotten this far. So I'm assuming that you've placed your shells. I'm assuming that at the fronts of your shells, you've placed a 5x and a 1x. And I'm assuming also that you've acknowledged, because of the minus up there with the gold box around it, that there definitively is one positive and one negative, right? And this is where we go from stuff we know to stuff we're just not really sure about. So we make a list now of the factors of 24, and they are 1 and 24 and the backwards. Go ahead. 4 and 6 and the backwards. Keep going.
12 and 2.
Yes, and the backwards. And what else? There's one more. It's okay. I got you. 3 times 8, right? So there's an exhaustive list of all of the factors of 24. And so there are 8 possibilities for this problem. There's 4 combos in 2 different orders each is 8. So has anyone found the winning combo? No. Got it? Good job. Got it. Right. I would just something to think about, and this might be, you might not be ready to hear this yet, but you would agree that 26 or negative 26 is a pretty large number, right? And so what I think about, and I said this earlier, what is special about this place where I'm pointing with a green arrow? Why is that an important space? Because it multiplies by 5, it gets buffed. Whatever I put in this green blank gets buffed by multiplying by the 5. So I don't want to waste the power of that space and put something wimpy there like a 2 or a 1.
You need like
I want to think about putting something there that when I multiply it by the 5, I'm going to get some bang for my buck, right? Does that help a little bit? Yeah. Mm-hmm. You guys get it yet? Again, I want to say, I would not do what I just did. I wouldn't put a wimpy number there and waste the power of the buff, right? You don't grab a power up in a video game and then go run backwards and hide behind a rock. Like, you take advantage of the opportunity. And so if I'm looking at what can I put here to buff it with the 5, I think let's start with the bigger numbers like 6. 6 is pretty big. And if this isn't buffed enough, then I'll try the 12 or the 8, right? But if I put the 6 here, then by default, I have to put a 4 here. And I'm giving that 6 a mega buff, because when those 2 on the outside multiply, what do they make? They do. They make negative 30x. And that might just be the perfect buff that I was looking for, because now what do the 2 on the inside make? And those, my guys and gals, add to make exactly what we wanted. Right? So you start to think about, hey, this actually isn't as random of a guessing game as maybe I initially thought. Put numbers where the buffs are when you want to buff. If you don't want to buff, then think about neutering numbers, putting weaker numbers in stronger positions, so on and so forth. Should I not say neutering? Is that wrong? Does that feel like not the right? I feel like it's the right expression in this case. Okay. Yeah. Yeah. So this is the final stage of difficulty. The way I always see it when I teach this lesson is there are 3 clearly defined phases. I see it with 100% clarity. In my mind, phase 1 was the first 5 or 6 problems that we did where there was no number in front of x squared. Phase 2 was the second phase that we just did where we had a number in front of x squared. Phase 3 is where we put a number in front of x squared that can be made more than one way. So this is where it gets as hard as it's going to get. And what I say is this: I can't even do this part in pen. I mean, yes, I could. You could too, if you're willing to do this. Can I say that that is the way the answer is going to look? I cannot. Because 6 is not the only possible way to make 6. Yes, and so I call these templates, and you don't have to call them anything, but I look at it like this. I have a top template and I have a bottom template, and you would have to agree right now that both of these templates are in the running. You cannot disagree with this. 6x and x make 6x squared, don't they? But, oh crap, so do 3x and 2x. So to make this even more annoying than it was before, now not only do we have multiple possibilities that we have to check, but we also have to check them in multiple different locations. So this is, I say, is like the top of the mountain as far as mount factoring is concerned. So let's do this. If I were to put a box around this, which I am, and say, what are my signs? What would you say? Okay, so I know it's a positive and I know it's a negative. I know there's one of each. I just don't know where they go, but that's what erasers are for. And as far as what are the factors of 14, they are 1 and 14 or 2 and 7. So honestly, there's not a lot of meat on this bone. There's only 8 things. There's 2 possibilities, which forward, backward makes 4, and then 2 templates in which to check them makes 8. It's not bad. So let's dive in. Which template, which combo? You tell me, because I don't care. So bottom template, and which ones do you want? What's that?
2 and 7.
2 and 7?
Yeah.
Like this? So we're picking bottom template. So we're picking bottom template, 2 and 7. Now, if we try this and it doesn't work, you cannot cross off 2 and 7 until you've done 3 more things. You have to try 7 and 2, and then you have to go to the top template and try 2 and 7 and 7 and 2. So every pair now has a lot of ways that it could work. Bless you. We clear? Bye. So let's see if this works. What do these make? And what do these make? 3 times -7 is, add those together, what do you get? I'm relatively certain actually that we do get exactly -17. So I think we just nailed it. We had a 1 in 8 shot and we got it on the first try. It's a 12.5% probability. Let's do another one.
Wasn't that what we were supposed to do
What's that?
for our next lesson?
It will be after quadratics is probability. Yes. Next one. That's a 3, by the way. I'm so sorry. That's so ugly. -43x plus 30. Right. Good job. So the fact that there's a plus in the back means they're the same, right? So then we default to our homie in the middle, and he's like, yeah, they're both minuses, BT dubs. But again, I find myself with multiple possible templates, right? I can't just go up here and say, boom. Because there's also a possibility that it could start with a 2 and a 2. The one nice redeeming fact here is that I could, using a pen, I could put a minus and a minus because I know damn well that they both have to be minuses, right?
In the show.
Yep. So the question now becomes, when I ask you, what do you want to try? You have to tell me 2 things, which template, which combo. So our combos are 130, 215, 310, 5, 6. And of course, the backwards versions of those. So what do you want to try? Which combo, which template? 310, which template? I need to know which template. This is the top template. This is the bottom template. 10 over here. Why would you do that?
Don't you want one number like this?
So I'm really proud of you for saying that. That, you know, I looked at you a while ago and you looked like you were daydreaming. And then you just said that and it made me go, she's been listening this whole time.
Yeah.
By putting the 10 there, you nailed it. You nailed it. By putting the 10 there, you buff him with the 4. Boom.
I'm just really trying to understand it, and sometimes my face is just like that.
No more explanations necessary. That was the most beautiful thing I've heard you say in a while. That was gorgeous. By putting the 10 there, we've buffed it. We've given it the power of the 4, and we've gotten ourselves a nice, monstrous -40x, which, look at that. If we pair it with this little puny -3x, check it out. Jackpot. First try. Good job. Good job. Good job, Peyton. Let's do one more, and then we're going to be done with this.
Yeah, my brain feels a little fried.
Okay. I'm sorry. 4x squared plus 4x minus 35. How many templates will we have?
Two.
Good. So we have a 2x template, and we also have the 4x 1x template. Not yet. Okay. The fact that there's a negative in the back tells me what?
Oh.
There has to be one of each. Has to be one of each. The guy in the middle, I don't need him. +4 is like, what about? I don't care about you. You don't provide me
don't
any
exist
information,
to me.
right? You're dead to me. All I know is that 35 told me everything I needed to know. That there's one of each. There's a positive and a negative, positive and a negative, and I might have to switch them. Who cares? And now we run through the factors of 35, and they are 1 and 35, and 5 and 7. There's not a lot of meat on this bone. So again, when you give me input, please tell me which template, which combo. Ready, go. Top template, bottom template. Okay, so Micah has spoken. He said, let's do 7 and 5 in the top template. That's the kind of information I need. He has a 1 in 8 shot of being right. There's 8 possibilities that could work, and he's obviously worked ahead and knows that this will work, right? Or was that seriously just a guess? Top notch. Your good instincts then. What do the 2 on the inside make? Positive 14x, because it's a positive 7 and a positive 2. And what are the outside? And if you add those together, what do you get? So I need to tell a couple things. First, I want to speak to the whole class. I already told you this, but I have to be gone again Monday. I'm going to leave you an assignment. It's going to be on Delta Math. And that is that. We clear?
Clear.
And I need you working. 2 of you in particular should listen carefully. I need you working for the duration of the class period. We clear? If you get done with it legitimately by actually doing it, then yes, you may work on something else. I think you know what
Is
I
it
mean by
fine
that.
that I went over there? To work with you?
Yes, it is. Okay, I'm going to end the recording here.